In this video, we'll take up the homework on coterminal angles and reference angles. For the first question, you're given the point on the terminal arm, and your job is to find the exact values for each of the trig ratios, the primary trig ratios. So if you're given the point, you have x and y, but what you don't have is the radius of the circle. So using the equation of a circle, x squared plus y squared equals r squared, you can solve for the radius. And once you have x, y, and r, you can solve for the exact values for the primary trig ratios. Sine is defined as y over r, cos theta is x over r, and tan theta is y over x. And I chose to rationalize the denominators for all my answers. So for question 1, for A, B, C, and D, the strategy was pretty much the same. Now for B, you notice that I just said that the radius is 5. So I skipped that step because once I saw the coordinates of the point negative 3, 4, then right away I knew that the radius was 5 because I saw 3, 4, 5 right triangle. If you don't see that, that's perfectly fine. Just use the equation of a circle, x squared plus y squared equals r squared, to solve for r. Aside from that, there's nothing interesting about 1. Okay, so for question 2, that's basically the same as question 1. So instead of a diagram, you're just told the point. So you need to imagine point E, F, G, and H. You need to know where that point is located. Like for example, for 2, 3, that's in quadrant 1. Negative 3, 5 is in quadrant 2, and so forth and so on. You want to know which quadrant the point is located in, because then you'll know whether the trig ratios are positive or negative. So for example, for 2a, I know everything's positive because the point is located in the first quadrant. But for 2b, I know that sine will be positive and everything else will be negative because we're in the second quadrant. Okay? So I guess you can argue that question 2 is a little harder because they don't give you a visual, but you can easily provide that for yourself if you want to. Okay, so for question 3, once again, I'd argue it's very similar to question 1 and 2. So for question, like for example 3a, they tell me that sine A is equal to 3/4, and A is in the first quadrant. So if you know what the ratio of sine A is, then you know the y coordinate and you know the radius. And using the equation of a circle, x squared plus y squared equals r squared, you can solve for what you're missing, which in this case is x. And because it's in the first quadrant, we know that x has to be positive. So for 3b, you'll notice that you're solving for y because you're given the cosine ratio. So you have x and r, and you solve for y. Reject the negative because b is located in the second quadrant. So be careful. Sometimes reject positive, sometimes reject negative. It just depends on where the angle is located. All right. So 3c, there you go. Point C. So they give us tan ratio, and tan is a positive 9/11, and it's in the third quadrant, which means sine and cosine is negative. In fact, you could put negative 9 here. Let's fix that up. Because x was negative, well, y was negative 9. And one second, let's just write that down first. X is negative 11, and y is negative 9. Which gives you the same radius, but just... yeah, I don't want you to be confused that x and y are positive. Because you're in the third quadrant, x and y are both negative. Okay, so for 3D, I didn't show as much work because once again, I saw something special. I saw the 5, 12, 13 right triangle. Once again, if you didn't see it, just solve for it using x squared plus y squared equals r squared. Okay, yep, so I have... I know that sine is negative for 3D because you're in the fourth quadrant. Okay, so what about question 4? For 4, they're asking me for 2 angles that have the same trigonometric ratios as each given angle. So what they're really saying is, can you look for coterminal angles? Can you look for coterminal angles? Or you can use the reference angle to figure out an angle in a different quadrant that will generate the same ratio. So 4a is sine 60 degrees. So I wrote 120 degrees because 120 degrees works out because sine is positive in the second quadrant. So sine 120 degrees will be equal to sine 60 degrees. 120 has a reference angle 60. Or you can do coterminal. Okay, so one more. Let's do another one. Cosine of 230. How do I know cosine of 230 is equivalent to cosine of 130? Well, cosine 230, that's in the third quadrant with a reference angle of 50 degrees. So it's negative and with a reference angle of 50 degrees. Well, guess what? Cosine is also negative in the second quadrant, so I just have to use geometry to figure out what's the principal angle if the reference angle is 50 degrees. So 180 minus 50 degrees is 130 degrees. And then the other angle I found was coterminal. So I took 230 and add by 360. So that's basically my strategy. I just established whether the ratio is positive or negative and identify the reference angle, and I can find a different angle that will give us the same ratio. For question 5, determine any 3 positive angles that are coterminal with 150 degrees. So just add by 360 or a multiple of 360 and you get the coterminal angles. For question 6, you're told that theta is obtuse, which means we're in quadrant 2. Express the length of OB. OB is your radius, so use the Pythagorean theorem. Okay. And then express the primary trig ratios in terms of x and y. Okay, there we go. There's OB. Now, if you want, you could rationalize the denominator. So you know what? Let's do that. So I'm gonna write sine b over here. So sine b is y root x squared plus y squared all over x squared plus y squared. You can do that. And you can do the same thing for cos b. Cos b is equal to x times root of x squared plus y squared all over x squared plus y squared. Okay, so both are acceptable, but I would prefer if the denominator was rationalized. Okay, for question 7, we're told that cosine f is 12 over 37. Now, since the ratio is positive, cosine could be in quadrant 1 or 4. We don't really know, but if they tell me that in part C, 7C, they say sine is negative. So if sine is negative, you cannot be in quadrant 1, so you must be in quadrant 4. And then you can solve for the other ratios if you know y. So y is negative 35. Okay, so hopefully the homework wasn't too bad.